This is RD Sharma Solution Class 12, Chapter 13, Derivatives as a Rate Measurer. Exercise is 13.1. Find the rate of change of the total surface area of a cylinder, TSA we can call it, of a cylinder of a radius r and height h. So we have to write the formula in terms of r and h when the radius varies. So the variable is radius here. So in this all sort of questions, the rate of change is the rate or the speed at which certain thing changes, increases or decreases. So total surface area is total surface area of a cylinder is 2 pi r plus h, or you can call it as 2 pi r square plus 2 pi r h. 2 pi r h is the curved surface area and 2 pi r square is the pi r square plus pi r square above and down. So when you add them, you get the total surface area. So this is the formula, and we can write this as, because we have to write in terms of r and h only. So 2 pi r plus h this is, and this radius is varying, so the variable is radius. So we have to differentiate with respect to the changing quantity, and which is radius here. So we have to do dt by dr, not dt by dh, okay? So 2 pi r square plus 2 pi r h, I've just added these two because just to show you that this is the addition of two surfaces area, which is the total surface area. So we are going to do this dt by dr. We have to differentiate r square here, it will be 2r. Here 2 pi h, the differentiation of r is 1. Now what do we get? 4 pi r plus 2 pi h. You can take 2 pi common here, you get 2r plus h. So this is your dt by dr, the rate of change of total surface area of a cylinder. Radius is varying. Find the rate of change of volume of a sphere with respect to its diameter. It's not with respect to radius, it is with respect to diameter. So volume of a sphere is 4 by 3 pi r cube. R is the radius, but we don't need radius here. We are interested in the diameter. So how do we do this? See, just have to differentiate it. But you are not going to differentiate the r. You are going to differentiate the r, but you have to write it in terms of the diameter. So you know that radius, twice of radius is diameter. So in place of diameter, you can write it as 2r, or in place of radius, you can write it as diameter by 2. Means you have to differentiate with respect to d. Please remember, not with respect to r. So diameter is nothing but 2r. So in place of r, you have to replace it by d by 2. Radius is d by 2. That is diameter divided by 2 is radius. So v is equal to 4 by 3 pi in place of radius, diameter by 2 whole cube. So what do you get? 4 by 3 pi diameter cube divided by 8. So 4 2s are 8, you get d cube, pi d cube by 6. Now you can replace this d by 2r anytime. It will be 2r whole cube. So dv by dd you have to do. See, I wanted d to be there because we can only differentiate with respect to r. But still it is saying d by differentiation with respect to diameter. So I'm just having a diameter here. So d cube is 3d square. Now you can write this as pi d square divided by 2. Now you can anytime replace d by r, or you if you don't want, you cannot, you don't do it, right? So this is d is 2r whole square, pi 4r square, this is going to be 2 pi r square. That is how it is going to be answered. Please remember, alright? So that is the relation. So you see, there are certain ways to do things differently. Find the rate of change of the volume of a sphere with respect to its total surface area when the radius is 2 centimeter. So rate of change of volume of a sphere with respect to the total surface, to the surface area, not total. So you have to find out some d by d thing, but it has to be dv, that is the volume of the sphere, divided by ds, which is the surface area. So you need to know the volume of the sphere, which is 4 by 3 pi r cube. We have already seen that. The surface area of a sphere is 4 pi r square. That also you know. But we have to, this is kind of a parametric question which we have already done in the previous chapters. dv by dr we have to find, ds by dr we have to find, then we have to find dv by ds, which is being asked in the question. It's not dv by dr or ds by dr. So the volume is 4 by 3 pi r cube, the surface area is 4 pi r square. So the rate of change of volume of a sphere, that is dv, with respect to the rate of change of volume with respect to surface area. So ds has to be there. And once you compute this or find out this, then finally you have to replace the radius by 2. Alright. So volume is 4 by 3 pi r cube. So first let us find out dv by dr. Then we'll find out ds by dr. And dv by ds can be computed by dV by dr divided by ds by dr. Again, parametric form. So dV by dr, ds by dr. And then once you find out the differentiation, then you will go about division. So I am differentiating r cube here. It's going to be 4 by 3 pi 3 into r square. That is going to be 3 get cancel 4 pi r square. What about this? 4 pi r square is 2r. Differentiating with respect to r. So you get 8 pi r. dV by ds is what? dV by dr divided by ds by dr. So you have 4 pi r square divided by 8 pi r, and dV by dr divided by ds by dr. What we did is this just thing. So this is dV by ds. So we can just make it simpler. So we have r by 2 here. And the question is asking not only this, but also the rate of change at radius equals to 2. So rate r 2 by 2 is 1. 1 centimeter is your answer. Find the rate of change of the area of the circular disc. Circular disc is just a circle which is filled circle with a thickness. And the radius at which we have to find out this rate of change is 3 centimeter. So the area with respect to the circumference. So let us call A as area, C as circumference. So area and circumference we need to know. We have just completed a question, and that question was also the parametric form. The same thing we have to do here. Area is pi r square. The circumference is 2 pi r. dA by dr we have to find out, dC by dr we have to find out, and then we have to divide them. So dA by dr. How about dA by dr? So dA by dC, in order to get this, we need to find out dA by dr, and differentiation of r square is 2r, you get 2 pi r. So this is 2 pi r dA by dr. And what about dC by dr? 2 pi r, so r is going to get eliminated, it is going to be 2 pi. Now dA by dr divided by dC by dr, that is going to give you dA by dC, and that is going to be 2 pi r divided by 2 pi, and you can cancel these 2 pi out. You are only left with r, and the question is asking at r equals to 3 centimeter. You can just replace this by 3 centimeter. dA by dC is 3 centimeter at r equals to 3. This is your answer. Find the rate of change of volume of a cone with respect to the radius of its base. So volume of the cone we have already seen, which is 1 by 3 pi r square h. In order to solve these questions, you need to know the mensuration part. Volume, the surface area, total surface area of different shapes. So volume of the cone is 1 by 3 pi r square h. We are calling it as a V. V is 1 by 3 pi r square h. We have to find out dV by dr. So this is simply differentiation of r, nothing else. H needs to be constant because the radius of the base is the varying quantity. So 1 by 3 pi r square will be 2r, and this gets 2 by 3 pi rh. This is your answer. Find the rate of change of the area of the circle with respect to its radius r when r is equal to 5 centimeter. So area of the circle, there are different ways. If radius is given, diameter is given, or the circumference is given, there are different ways in which we can represent the area. But we'll go about with pi r square only. So area is pi r square. The rate of change of area with respect to radius is dA by dr, which is going to be 2 pi r. The area changes to the circumference. It's fascinating, no? When you differentiate it. R is equal to 5, so just put R as 5. That is going to be 10 pi, and that is going to be 10 pi. Please remember, you have to follow the units being given. So it's 10 pi. That is the answer. Find the rate of change of the volume of a ball with respect to its radius r. How far is the volume changing with respect to the radius when the radius is 2 centimeter? So whatever we will get, we will finally change or replace r by 2. So volume of the sphere is 4 by 3 pi r cube. It's 4 by 3 pi r cube. So volume is equal to 4 by 3 pi r cube. And you don't have to do anything, just differentiate it. dV by dr, and 4 by 3, it's pi, r cube will be 3r square, and you get 4 pi r square. The volume changes to the surface area, okay, whenever you differentiate it with respect to r. Now dV by dr at r equals to 2 is 4 pi. In place of r, replace it by 2 square, that is going to be 4 4 is 16 pi is the answer. And this is on the left. I just gave you a reference. That is how you're going to follow and write in your exam. The total cost C associated with the production of X unit of an item is given by Cx equals to this. Find the marginal cost when 17 units are produced. So there is no catch or trick in this question. Simply differentiate and place X as 17 when the differentiation is completed. So dC by dx you have to do, because this is the production of X units of an item and the total cost is already being provided. So marginal cost when 17 units are produced, we have to differentiate it. X cube will be 3x square. x square will be 2x, and 15x will be 15 only because x will get eliminated. 4000 will anyhow will not come because differentiation of a constant is going to be 0. So in place of x, just replace it by 17, and I'll give you a final solution, this one. I hope you can do this. 17 you replace here after differentiation of this particular expression, and they'll get 20.967 rupees as the final answer. This question is almost similar to the previous one. The total revenue received from the sale of x units of the product is given by this expression, and this expression has to be differentiated. We have to find out the marginal revenue at x equals to 7. Differentiate this where after differentiation, in place of x, replace it by 7. So this is 13. X square is 2x, so it will be 26x. Here 26x will be 26 only. 15 will get eliminated, and x equals to 7. It will be 26 into 7 plus 26, and that is going to be your final answer. And the final answer is in rupees at 208 rupees. The money to be spent for the warfare of the employees of a firm is proportional to the rate of change of its total revenue, marginal revenue. If the total revenue in rupees received from the sale of x units of a product is given by this expression, find the marginal revenue when x equals to 5 and write which value does the question indicate. So the question is having a lot of things here, but we don't have to worry about because we are only interested in the differentiation. So when this question will come in your exam, then you will be perturbed. Oh, from which chapter it has. This chapter we know that we have to differentiate it. So we have to differentiate 3x square will be cx, 36 will be 36 only, 6 into the value is x equals to 5. The required marginal value will be 66 rupees. There's one more thing here. Write which value does the question indicate. So this is indicating the extra money spent when the number of employees increased from 5 to 6. When x equals to 5, you got this. When you actually put differentiation, then you are actually computing the rate. So this is all about this discussion. Thank you so much and take care of yourself.